In this 3 steps to sketch, we're going to graph an unshifted or basic secant graph. Y equals 1/2 secant of pi x. So here's our template for a basic secant graph and our equation and grid. So we've already said this is a basic secant graph. Notice it follows that general form y equals a secant of bx. Okay, we don't have any shifting going on here, so that's how we know we can use this more basic method. And let's get started. So step 1 is to find our companion equation and the essential information. So our companion equation simply takes our equation and replaces secant with its reciprocal cosine. So we're going to graph y equals 1/2 cosine of pi x. If you don't already know how to graph cosine, I'll post some links in the video description to help you out with that. So again, we'll graph this companion equation, and then in step 3, we'll actually translate it, if, for lack of a better word, into the actual secant curves. Okay, so let's first start by analyzing this companion equation. Our base graph, so A is going to be that coefficient in front of cosine. That's going to be 1/2. So that tells us that our amplitude is 1/2. That's just the distance from midline to maximum or minimum. We see B is the coefficient of x, so in this case it's pi. And that tells us that we should have pi cycles, so 3.14 cycles that happen between 0 and 2 pi. And then it also helps us find the period. To do that, we calculate 2 pi divided by b. So 2 pi divided by pi is simply 2. So our horizontal length of a cycle is 2 units. And now that we know this basic information, we can choose how to label our axes. So we're choosing how to count our tick marks. And the horizontal axis is the one you want to pay closest attention to. And with this 3 steps to sketch method, we take our period and we divide by 4. And this ensures that in step 2, when we're plotting our basic companion pattern, all the points will align with our horizontal tick marks. And that just makes for a nice clean graph. All right, so again, our horizontal scale, take your period, divide by 4. So 2 divided by 4 simplifies. We'll count by 1/2 when we label our horizontal axis. And then for our vertical axis, we'll count by 1s. All right, let's take a minute and label our axes. So horizontally, we're counting by 1/2. So that's 1/2, 1, 3 halves, 2, 5 halves, 3, 7 halves, 4. And if you're working alongside, I'm going to pause and label the negative part of the axis. All right, so here's how that looks. Same values, just negative. And let's label our vertical axis, counting by 1s. There we go. We have a nice grid set up and labeled. Now, before we move on to plotting our companion pattern in step 2, I like to find the asymptote generating equation. And to do that, take the inputs of your secant graph, so that's pi x here, and set them equal to pi over 2 plus pi k. And we do that because those pi over 2 plus pi k, those are the original secant asymptotes. So if you look at the graph of y equals secant x, you'll see those are the asymptotes. And when we take our inputs of the secant function and solve for x, we're essentially applying that all the horizontal transformations to those asymptotes. And I like to do this at the beginning to use as a checkpoint for looking at the final graph, making sure everything looks like it's in place. I'll post some videos later on with some more examples about finding asymptotes of secant graphs, and those will go into a little bit more detail. So if you're interested in that, check those out when I post them. All right, so back to the equation. We need to solve for x, so all we need to do is divide every term in the equation by pi. All right, and let's write our finished equation in the blank in the template. So we have x equals, it'll be 1/2 when we simplify, the pi over 2 divided by pi, and then plus 1k. So k is simply an integer, and depending on what integer you substitute in, you'll get a different asymptote for the final graph. So if you let k equal 0, we should have an asymptote at x equals 1/2. If k is 1, you'll get the asymptote x equals 3 over 2, or 3 halves. If you let k be -1, you'll see that there should be an asymptote at x equals -1/2. So it's just a nice thing to kind of know ahead of time. So when we get to step 3 and when we're plotting our finished graph, that should match with our asymptote generating equation. All right, now we're on to step 2. We're going to plot our companion pattern. So essentially we're graphing the companion equation. I'm going to use light blue. Make sure you mark this lightly. This is not our final graph, just our companion pattern to help get us there. So remember that a cosine equation that is unreflected should have a pattern of maximum, x-intercept, minimum, x-intercept, repeat. And we're starting on the y-axis. So we look to A to get our y-coordinate. We see A is 1/2, and so our first point of the pattern should be our maximum at 0, 1/2. At the first horizontal tick mark moving right, we should have an x-intercept. Moving on to the second horizontal tick mark, we should have our minimum, and that occurs at the opposite value of A for the y-coordinate. Okay. Another x-intercept at the next horizontal tick mark, and then you would repeat. So here you've graphed one cycle of the companion equation, y equals 1/2 cosine pi x. So hopefully you see why I said it's nice to know and be confident in graphing cosine before you start to graph secant. Okay, we're now ready for step 3, which is recip, sketch, and repeat. So recip is actually just taking the points from our companion pattern and changing them into what we need for secant. So let's review. We know that the maximums of our companion pattern, the maximums of cosine, will turn into local minimums for our secant curves. The minimum of our companion cosine equation will become a local or relative maximum of our secant curves. And then the x-intercepts change into vertical asymptotes. Okay, so let's go ahead and plot those points. And if you want to sketch in as we go, you can do that too. But we have the maximum that turns into a local minimum. We have a vertical asymptote from our original x-intercept. Our minimum turns into a local maximum, another vertical asymptote from another original 0, and another local minimum. So let's sketch this in. So here is what these secant curves look like. Just like that. That's one cycle of our graph, y equals 1/2 secant pi x. Now let's go ahead and repeat. So you can sketch in the rest of that curve there for secant. We have another vertical asymptote. At this point, if you want to use your asymptotes equation to double check this, we should be able to substitute in k equals 2, and that'll give us an asymptote here, this one at 5/2, or 5/2. All right, we have another local maximum here, sketching in that curve. Next vertical asymptote comes from letting k equal to 3. And then we'll sketch in another curve that has a local minimum. And remember, terminology, local or relative minimum just means that it's the smallest y value in the small area around where you're working. It's not the absolute lowest, not the absolute minimum, but it's in the area, a local minimum. All right, let's work the pattern the other way, get a couple more cycles here. Okay, so here's the vertical asymptote that comes when you let k equal -1. We have another curve that has a local maximum. If you substitute in k is -2, you'll get this asymptote at x equals -3/2. We have another curve with a local minimum. Another asymptote, test it out. K should equal -3 here. A local max. Another asymptote. And another partial curve with a local min. So this is 4 cycles of our graph using the 3 steps to sketch method. Keep practicing your graphing as you work more and more examples. Graphing secant should become easier and easier. It should become almost second nature, just as easy as it was to graph the original cosine equation. I'll post some links to more examples in the video description, and I'll also have links to playlists on how to graph other trig functions, so check those out if you're interested. Thanks for watching.